Okay, so Leetcode practice time. Maximum difference between node and ancestor. Alright, so again, two goals. The first one is to see how to solve this problem, and then we are going to put some code here. And the second one is how we should behave during a real interview. So let's get started. So remember, the first thing is to always try to understand the question itself, what it is asking us to do, and also at the same time think about some edge cases. If you have anything that is unclear to you, please bring up the question to the interviewer and ask the interviewer to clarify. So let's try to read through this problem. So given the root of the binary tree, find the maximum value v, for which there exist different nodes a and b, where b is equal to a dot value minus b dot value, and a is an ancestor of b. Alright, so a node A is an ancestor of b is if either any child of a is equal to b, or any child of a is an ancestor of b. Okay, yeah, essentially like a and b is on the same path. So let's take a look at this example. We have this tree, and we have like those two nodes, the share. So 3 has the ancestor 8, so the difference is 5. Similarly, 3 and 7, 8 and 1, 10 and 13. Well, yeah, so the largest one is 7. Okay, I think I pretty much understand what the question is about. And let's see the constraints. So the node value is, so node is going to be non-negative integers. So the number of nodes in the tree is between 2 to 5,000. So for sure not to be an empty tree, and for sure there are at least 2 nodes. Alright, so the next step is about finding the solution. So what will be the solution for this? So for this one, I think we could use some DFS thing, recursion, and so what we pass into it is a current maximum value and a current minimum value on the pass. So you remember, like for a DFS, we just go as deep as we can to one pass, and then search the other pass. So it's like when we search through this pass, we just try to at the same time we pass in two things. One is the maximum value on the pass, and the second one is the minimum value of the pass. And then at the same time we just compute the absolute value between the maximum and the current node and the minimum on the current node. So for sure it is going to get us the largest difference between the nodes on the pass and the current node. Alright, so this one we are going to visit all the nodes, so the runtime is going to be all of n, and is the number of the nodes within the tree. So the next part is about coding. So for coding, speed and the correctness, and of course the readability. Alright, so let's see. For this one, max ancestor Dave, and tree node as root. Okay, so let's see, if I define a helper function, let's define a helper function, let's call it df, or max, and or let's just overload it. So this is the tree node root dot value and root dot value. So this is a DFS function I talked about. So let's define it. Max ancestor, the tree node, this is the root, and max value, and this is a min value. Alright, so okay, so this one is going to return an integer. So first let's try to see what is the exit of it. So if it is if root dot left is equal to none and root dot right is equal to none, which means it is a leaf node, then what we are going to do is we are going to return so we are going to return mass dot max root dot mass dot abs okay, so abs root dot value minus max value, and the mass dot abs root dot value minus main value. Yeah, so if it's a leaf node, that's it. And if it's not a leaf node, what we are going to do is so if it's not a leaf node, we should first see the left and the right. So int left max is equal to max ancestor def max left, let's say it is equal to -1. So if left max, if root dot left is not equal to none, so left max is equal to max ancestor, this is root dot left, and we are going to pass in the mass dot max the max value and the current root value. It's gonna be so it's gonna be mass value and the root dot value, and this is mass dot main value and the root dot value. Yeah, so we pass the max and the min on the pass of it. Yes, we go to the left and then yes, that's correct. And similarly, we are going to have right max as equal to -1. So if root dot right is not equal to a non-pointer, then right max is equal to max ancestor def root dot right, and yeah, so similar things like this. And the next thing is so the next thing is we are going to try to compute for the current node what's the difference between the max diff between the current node dot value with max value and the mean value. So let's say right is equal to, okay, so int car max car value is equal to mass dot max mass dot abs root dot value minus the max value, and mass dot abs root dot value minus main value. Yeah, so that's the current thing. So it's alright, so current, let's say it's current max value. So if current max value is equal to mass dot max current value with the left max and the right max. and we finally return the car max value. Alright, so let's see. So let's take a look at example for testing. So remember, after coding, always test your code. So first you need to go through a piece of example and explain how this gonna work. At the same time, do some sanity check, checking the logic about different branches. This is about communication testing, and then after you feel confident and you and interviewer feel good about this piece of code, it's time for us to set up some different test cases to increase test coverage. So let's see for this one. Like this tree, we are going to say okay, left. So starting from 8, we are going to call root and 8 8, and because it's not a leaf node, and then we are going to go to the left tree. So currently max ancestor is equal to so we are going to call the node passed into it and 8 and 8, and we are going to, so when we call it this, so regardless, like other things which are like get the left max and the right max, the thing I currently know, we compute the car max as equal to 8 minus 3 and 8 minus 3, so it is going to be 5 here. Alright, and similarly, I would say this is just like a replication on the left tree and the right tree, like doing same operations. So I think it should look good. Let's give it a try. Alright, so it's good, and alright, so everything looks good. So this is pretty much about the question and the solution. So if you have any question about the solution itself, please leave some comments below. If you feel this video pretty helpful, please give me a thumb up and help subscribe to this channel, and I'll see you next time. Thanks for watching.